Hello everyone. Physical keys are getting replaced more and more by electronic alternatives, also using RFIDs. And there are many pitfalls in implementing RFID key access systems. And our next speaker will shed a bit of a light into what you can do wrong and how you can exploit it. Please give a warm round of applause to Adrian Dabrowski.
So, welcome to the RFID Treehouse of horror. Well, first a short overview. I will show you some centralized key systems in Vienna, mechanical key systems in Vienna and used in Vienna and Austria. There are apparently a lot of these systems in Austria, but probably in other countries too. Then I will take a short detour on explaining what RFID is and how it works. And then I tell you about my crusade, how to hack citywide access control systems. So let's start. Apparently, I think that it's in other cities it's the same, but in Austria we have a lot of these centralized keys. For example, the WEZ 2000, the Wiener Einheitszylinder 2000, apparently so it's the Viennese Unified Cylinder 2000, apparently from a time where everything sounded cool when you added 2000 to it. So this is actually a key used by the fire brigade and others to open all the backyards, to open all the posts and gates and bars or parking spaces. And so if you need a parking space or need to deliver something, this is the key to get. There are other interesting keys. Actually, the regulations on this key are like this. You're not forced to use a padlock that accepts this key. But if an emergency service needs access, they will break your other padlock open and you will not get rain-barraged. Also, you're not allowed to use a padlock that has a security level that is too high. So yeah, basically everyone uses this one. There are other interesting keys, for example, this one. It's for electrical cabinets. Actually, it was for electrical cabinets, but then, like with other systems, there's some kind of application creep, similar to permission creep, where someone aggregates permissions over time. Keys or actually all kinds of solutions tend to aggregate additional use cases. So, for example, this key was actually specified somewhere in the 60s only for authorized personnel for electrical installations. And it used indoors and outdoors, and in the meantime, it's also used for circuit breakers, for gas, for heating, for water, for everything. So basically, yeah, some power grid companies started to use another key now since 2009. It's a magnetic key lock. It's very complicated, but actually every party in a house now can get a key to access only the circuit breakers for their level, for their floor level, and not the other ones. But basically, for all other buildings in Vienna, they're still using this key. And there is a third very interesting key that when I talk to people abroad, they first don't believe me. It's the Z or BG key. And this key actually is very interesting because it allows you to enter almost all residential buildings in Vienna. The story behind this is like this. There was a time where the caretaker needs to be available during daytime, and when, for example, the post wanted to deliver the mail, then the caretaker would open them. But then this obligation was cancelled, and It was also the time where all these door intercom systems were installed. So someone had the brilliant idea, let's put a small cylinder that bypasses the door intercom system and just opens the door. So also this key is used for garbage collection, because in Vienna all garbage is collected in small rooms that are accessible either from the staircase or from the outside. So actually this key, in the mid-90s, when I first came across this key, it costed like 150 or 200 euros on the black market. However, in recent years, the price for this key has fallen to something like 10, 15, sometimes 20 euros. So basically, it became very popular actually, because after the post-delivery services use this key, then additional services, like in the case before, got this key, some as official users like fire brigade and emergency services or garbage collection. Then there were Supreme Court decision. The newspapers made this decision or went to the Supreme Court because they wanted to deliver the newspaper to the front door. And then there were a lot of unofficial users like advertising distributors, broking, sales agents, and maybe occasionally also homeless people or burglars. So since this key is now, it became very popular on the black market, let's say it like so. So since 2006, there is a new way to secure your door, or because before I go to the next slide, actually, if you have the Z key and the power key, you don't need the key to every individual apartment in a building, because when you get into the house and turn off the power, I think that people will come out by themselves. I just think. So since it's terrible insecure, since 2006 there is a new system. It's called BG, and the system uses electronic chip cards or RFID cards, and tries to evade all the shortcomings that these mechanical key systems has, like blocking stolen or lost keys, blocking duplication of keys. It's all the things that they are supposed to do. And also the new system allows the caretaker or the property management to distinguish between different user groups. It's a little bit small, but he can define if, for example, advertisement is allowed in the house or not. So, as I said, it was introduced in 2006, and in 2009 it has had about 4,000 installations in Vienna, and last year it was like something about 9,000 installations, and by now they should have gone about over 10,000 installations. And since the last year, they're also expanding to other cities in Vienna. The mechanical key lock actually is used in wide parts of Austria, not only Vienna. I've seen the same key in Linz, in Melk, in Tulln, in Wiener Neustadt, in Graz. So that's actually all over in eastern parts of Austria. So these are some of the claims the manufacturer makes. Maybe it's a little bit small. First, they say it's unclonable, and second, they say they have these testimonials like, "Oh, since I installed this lock, the series of break-ins have been stopped," and stuff like this. They started a big marketing crusade against the old mechanical system. However, fun fact: there are 100% subsidy of the company that is said to invented the mechanical key in the 70s. So when this key system was installed, this electronic key system was installed in my apartment building, I was like, challenge accepted. later it even became my diploma thesis. So now a small detour, because I had no idea about RFID, and I looked at several RFID systems, and I will show you first how RFID works, because RFID actually is not a standard, it's a concept. And depending on how far you get back in the history and what book you read, they sometimes say, yeah, the roots are in the Second World War for friend of foe detection and stuff like this. However, nowadays you have quite a lot of different RFID systems, and yes, actually before I show you the next slide, everyone who studied electrical engineering, please look away, because it's a really oversimplification of the thing. But I wanted to show. It's for those people who have no idea in electrical engineering or in physics. So basically, you have all kind of different frequency, all kind of different systems and physical properties these RFIDs rely on. Mostly it's like this. You have a passive transponder that gets its power supply and its clock and its data over the air, over some kind of physical channel, and then send something back. There are other systems which are semi-passive that have their own batteries, for example. If you're in daily life, you will mostly find 125 kilohertz tags called low frequency tags and 13 megahertz tags called high frequency tags. And basically, it works like this. Let's think of a transformer. You probably know it from high school. So basically, you know, if you attach alternating current, it transfers power over a magnetic coupling to the secondary coil. So where is my pointer? Here. So in the second picture, you see if I close the switch, I can transfer power, and I also transfer the clock signal because I have some alternating current. The second thing is so I can transfer data to the secondary coil by simply switching on and off the primary coil. The second thing is, how can I transfer data back over this transformer? And this is done mostly by load modulation in the systems I talk about. Basically, if you add additional power sinks, then also because of conservation of energy, the current on the primary coil also is higher than before. So by switching on and off some load, you can transfer power back to you can transfer data back to the primary coil. Because of these two systems, usually you have a completely different downlink protocol than an uplink protocol because they are very different. However, you have now the four basic properties that are transferred over air. So when I remove the transformer core and just pull it a little bit apart, I have something like an air transformer. And now I have a very bad coupling, but it's enough to transfer a little bit energy and a little bit data over this air gap. So you can make some kind of taxonomies. There are just very, very dumb RFID tags that just have a presence or 1-bit tags. You usually find, for example, in burglary alarms. You have tags that just produce an identification number, and then it goes up memory tags, which has some kind of EEPROM or flash memory, crypto tags that either have crypto functions on it or cryptologically encode or encrypt the data channel, and then you have really wireless smart cards where you can even put your Java applets or cardlets on it, some custom applications. Basically, there are a lot of ISO standards, there are a lot of proprietary standards, and there are ISO standards. However, they basically only specify the transport layer and mostly don't specify any encryption. Just a short overview which tools, more or less professional tools, you can find to debug RFID. So for example, on the left side, you see the Comprehend tool. It's a very neat device because you get like Wireshark style traces you see on the bottom. However, this device costs, depending on the options, like 10 to 20,000 euros. Okay, there's this EIK demo tag, which costs about 600, 700 euros. It's still a lot of money. And there's the Proxmark 3, you probably already heard on previous CCC lectures in the previous years, which costs about 250, 300 euros. However, the Proxmark is a very neat device. It supports low frequency and high frequency tags. However, the software is kind of potpourri of different styles and different qualities. And for what I have needed for my project, this part, actually I have had to rewrite a whole bunch of code. And after that, I realized that I have to go deeper because there were some issues with glitches. And then I decided to make my own simulator, but also because of other reasons. I will get on that later. Because, you've seen they're all very expensive. And the thing is, I think cheaper exploit is better exploit. Because every time you have something like, oh yes, it's academically broken, but you need something like 10,000 euros to break it, then every manufacturer will sit back and say, well, that's kind of a security. I mean, if it costs that much to break our system and you secure something that is less valuable than the cost of an attack, no one will do it. So you have to find very, very cheap attacks to circumvent the sayings. So let's make a small detour about different RFID systems I encountered in Vienna. So for example, there is this NFC ticketing system by the Wiener Linien, the local transport company in Vienna. And basically you can touch your phone on the sticker and then you buy a pass. Funny thing about this one, I also often get asked, what's the difference between NFC and RFID? Is it the same? Because most people use it interchangeably. So actually NFC is a higher protocol and data layer on top of the transport layer of RFID. You can use NFC on different card systems, but it then has a standardized data format. So like HTTP on TCP, for example, or on other protocols. So you can buy these tickets. And a funny thing about these stickers is, don't get distracted by all the bubbles. The interesting thing is here on the 25 bubble. Basically, they use MyFair cards, and you always group 4 page memories to one sector, and the last page memory is like the access control with all the keys and the access control permissions. And the funny thing is, when they were writing their text, they had something like an off by 1 error. They started writing the security page just always in the next sector. So they're revealing the secret keys, and secondly, they left the unused sectors unprotected. So you can use it as a dead letterbox by leaving messages for your friends by passing by with your phone. Another thing, this brand of coffee machines you'll find in Austria, in universities, at airports, and other places, office buildings. And they have this electronic purse, which is based on MyFair. Actually, when Carsten Knoll et al. And others already presented it like 5 years ago, how Crypto One works and how you can break it. So it was like 2 minutes for me to see what's on this token. Then I just added €1 to it and make a difference, and could actually write any amount of money on this tag I'd like to have. Very interesting. I mean, it's like 5 years ago. They have no way of disabling this or getting a new system. I will come to this in my conclusion later on. Actually, that's a very hard problem on how to design an update path. Also, they use some kind of key that is derived from the unique ID of the cards. But basically, you either break these keys or you can use UID rewritable MIFARE cards, which are available from China. Actually, I've not found any offline countermeasures, like they could make something like an offline history check or collect the data, because once a week a technician has to visit these machines at least once a week and refill it and something, so they could collect all the data and then at least blacklist these cards that don't fit into a plausibility check, but they obviously don't. Just to make sure, I have not used any of these funds over the amount that I've charged it. Another interesting key system that you find all over the place is this AM4102 based. Actually, this is the kind of alarm and access control systems you get in home markets and hardware stores and electronic stores. Also, actually, these are very, very dumb keys because, as you remember the pyramid, they only have this unique ID, and actually what they do is whenever they get into a reading field, they just start to broadcast their ID in an endless loop. So, and actually I also know an insurance company in the center of Vienna that used this key system like something like until a year ago. Then they switched to a new one. And there is a very nifty chip from Atmel that is basically a radio frequency powered function generator. So it has a EEPROM and some kind of controller, and then if you look into the data sheet, you will find, well, I can choose all kind of modulating schemes. I can choose different data types. I can choose different divisors. So basically, it's a function generator. And by a pure chance, you can program it that way that it produces the same signal that an original chip would produce. I don't know why Atmel developed something like this, but it's a very convenient device. And you find like these Chinese copying machines. You just have to put your original key there, then put this rewritable Atmel chip there, and it's copied. Also, confronted with the low security of these UID-based systems, the property or building management often states, well, yes, maybe it's not that secure, but it has one certain feature we are very proud of, and that's very convenient. It's blacklisting certain keys when they get stolen or when people lose their permission to enter the building. So I thought, interesting, is it really like this? I mean, okay, you have now something like 48 or 64-bit key space, and searching it would take like hundreds of years. So, is it really that secure? So I looked at a key system that basically works the same at my university. It's for the technical laboratories, electrical engineering laboratories. And what I found is, so I spoke with the administrator, and he gave me an anonymized copy of the access control database. And then I make some very easy statistical analysis by just making a histogram of it. And basically, yeah, it's a little bit small, but this is like you plot the key range on the x-axis, and you see, well, basically almost all the keys are in one range. So I zoom in and I zoom in, and I see like, oh, they have like, apparently they bought like 5 batches of cards. And when they are produced, they are numbered one by one. So basically, that's somehow ineffective when you're blocking the UID, because when the card gets stolen and you block this UID, I have this chart here on the left. So when you just take an UID that is one off, up or down, you have a 93% probability of finding another valid UID. And with 2 up and down, you have like 98% probability. And basically, if you're for this alarm systems or access control systems you buy in a hardware store, it's probably the numbers are not that small, but still you have like, you get one card and you know more or less the range where to look for other cards, because obviously they also bought this cards in batches. So one thing that manufacturers of this card should really do is randomize their UIDs when they really sell like these unsecure systems. So at least randomize it. A nice project made by Miloš Merjak. He done a lot of talks in the recent years here on the CCC. Is this sniffing device. He actually uses just a USB audio adapter to sniff this 125 kilohertz tags. This is possibly because the modulated data is like in the range of 4 kilohertz, and well, you know, sampling theorem, so you need at least 8 kilohertz, or maybe just 16 kilohertz, and you can sample it with your audio card. This is just a sniffing device. I wanted to build something as a side project for my talk. It's not finished actually, but the idea was, well, let's build a device that just sweeps through a ID range, and it should be cheap. So the idea is I just take a phone and use the audio output to a small circuit with a transistor, and it then modulates the signal and just sweeps through all the UIDs in a certain range. Actually, I wanted to present it here, but it wasn't finished by now, but I'll probably release it in 2 or 3 weeks. There are some KFETs with it, because you have no return channel. You're not synchronized with the sender. However, with my calculation showed that you only have to guess the carrier frequency within 1%. And the rest should be done by the Manchester encoding, which is self-synchronizing. So this should circumvent like a lot of these home market systems. I will later talk about how why I think that all these insecure systems will not go away that fast, even with so simple hacks like this. I forgot to mention something on the previous slide here. Because actually, if you look at this block diagram, there is this analog front end. And when you want to build your own simulator for tags, you have to make an analog front end. And actually, there's a lot of literature on how to build RFID readers, but almost none on how to build tags, interestingly. However, as I'll show you later, it's actually not that complicated, because also the manufacturers want to make cheap tags, and so they just rely on very simple digital circuits and don't want to mess around with hybrid circuits. So let's get back to the BG system. So first step is reconnaissance. I need to get a door unit. I don't want to steal the one that's in my apartment building. And I also don't own real estate that could be upgraded to the new system. So I contacted the general distributor, but they told me, well, actually, it's only sold by locksmiths and electricians, but they can name me some wholesale distributor, downstream wholesale partner. And with the reference that I'm coming from this general distributor, actually the downstream distributor or the wholesale partner actually sold me one. And I dressed up a little bit and said, okay, I'm building owner and want to upgrade my building, and I even got discount because I was a new customer and everything. Actually, last year I found there's now a web shop that also sells them, but back then there wasn't. So now I had this hardware device, I took it apart, looked at it, identified some components, and saw, okay, they're using some Texas Instruments chips for the RF front end. So I built a very small sniffer, and yeah, you see, very small. It's just a so-called envelope detector, and I could start it. This is a oscilloscope trace. You see some bits here appearing out of the signal there above. Basically, it's just a diode and a low-pass filter. So actually, you could start decoding some bits, and it reassured me that I have to do with some cards that is based on ISO 15693 standard. So the next thing was how to get real user cards. I mean, okay, for example, I could start as a volunteer at the Red Cross and then work my way up to the point where I get handed over a card, but this takes like maybe a year. Maybe I know someone at such an organization and he can borrow me a card, but I don't know, so I cannot do this either. Maybe I can buy a long-range reader. However, long-range readers are quite big and power-consuming and heavy and very expensive, like they start at 2,000 euros. And this is a picture of such ski gates. And seriously, I don't have this money. But what I have money for was some kind of, let's call it mid-range reader. It's like a reader that's 25 centimeters in diameter. And I packed a small microcontroller and a very big battery pack on it, and a small external memory, and went to my post office. And really, for about €5, I could convince them to send this parcel back home to me. So while it was in transit, it simply recorded all the keys. Every full second, it recorded all the keys in vicinity. Also, I didn't trust the Austrian Post very much, so I put a very big battery on it. I didn't know how long it takes them. Yeah, and it worked on the first try. So I had a key sample. Yeah, so therefore I could show that everyone can get samples of these key cards without knowing anyone or investing a lot of money. Just a side note, what would happen if someone found this parcel like suspicious and reported it to the police or something like that? I would probably have been woken up by the anti-terror squad. So that's why I put a small note into the parcel saying, okay, it's an experiment, here's my phone number. However, it didn't happen. So the next thing was, yeah, I've built a small sniffer, and then I want to extend it to an emulator, and then I wanted to do some testing, like fuzzing and systematic testing with the door opening unit. And actually, it was kind of interesting thing, because programming such thing is quite tricky, because you have to keep the timing exactly to the original, And actually, you are started to program with the oscilloscope behind you, because every time you receive something, like in this case, this is the bits that's coming in, or the demodulated signal. And actually, it's the modulated signal. And then I have to demodulate it. And actually, you start like interweaving different loops, like you receive a bit and you try like to decode it, and then also do the checksum calculation, all while you're receiving. And because afterwards, when the request ends, you have actually almost no time to prepare an answer. You have to do all the things while you're receiving this. And also for sending, like I've misused 2 PWM generators on this very cheap microcontroller that like trigger themselves. So the one triggers the other, and the other way around. And it was quite an experience, but actually, I could then use this for systematic tests and UID emulation and card replay attacks. And I've designed it that way. This is my prototype here on the right. You can see here is the original door opening unit. This is my microcontroller. This is the analog front end, and these are the antennas, one stacked on another. And actually, the whole setup costs like less than 20 euros. I can briefly show you how it looks like. It's actually quite simple. I was surprised that the analog front end actually isn't that hard. I mean, I've never studied electrical engineering. But basically, you have here your resonant circuit, you rectify it, and then you have an output transistor here, and an input buffer, and yeah, that's everything. And then you feed it into your microcontroller and write your program. With all the testing equipment now I could build a model of the inner working. So I built like this flow chart showing how it works, how the checks are, because it's kind of weird how they access the cards. And also it has some kind of brute force protection, so every time I made a test, I have to simulate the removal of the card, which takes a little bit time. But at the end, I could analyze what different cards there are and how it supposedly works. So basically, there are 4 types of cards. There are user cards with encrypted data in it. They have like 3 sectors for which always have like 3 memory pages. There is master card or ownership card and programming card. They work together. You need the ownership card with the programming card to make changes to the configuration of the device. And then there is the user cards are these 10 groups. I showed one on the earlier slides. And there is 11th group that's called Baukart, or in former times it's called test card. I looked it up using the Internet Wayback Machine from the vendor's homepage. And the interesting thing is the first sector is unencrypted. It just has some kind of checksum. And the second and the third sector are somehow encrypted based on the UID of the card. However, the Baukart only uses the first sector, so it's completely unencrypted. For what reason ever. So actually, there are 2 main findings: the Baukart and the rest of and the second one is that the manufacturer assumed that the UID is not duplicatable and not changeable. So that's the wrong assumption that they made here. I also did some basic. I'm not a crypto analyst, but I did some basic tests and brute forcing, but didn't reveal any much. So now it's time for evaluation. After all, that was my diploma thesis. So I went to 110 house entrances in Vienna and tested them. So basically, 92% of residential houses in Vienna use either the old mechanical key or the new electronic key. And out of this of this 92%, 16% use the new electronic variant. So actually, I was able to transfer the Baukart to an old ski pass. And 43% of the installations could be opened with this ski pass. So what could be more Austrian than a ski pass? So the costs for this attack like €2 deposit in the ski resort of your own choice. Also, I made a small Android app for my NFC phones to reprogram ski passes. I must say the Android RFID NFC API is really terrible. Yeah. So now, as I said, 43% could be opened with a reprogrammed ski pass and 93% could be opened with the card simulator. What's with the 7% rest? I'm not really sure because it was like, yeah, I didn't know maybe the lock is broken or maybe something other thing I couldn't test for this. Also, it was quite funny because I was a little bit afraid, okay, I'm going there around in the city and testing all the entrances. So I made up some kind of cover story. I got this worker's jacket to look like a technician. But actually no one cares. So as I already said, the card emulator can be built for something like a little bit less than €20, even if you have to produce your own PCB in a batch of for 10 pieces and then buy all the parts, so less than €20, which shows that you can actually circumvent the new system with actually almost the same amount of money that you could circumvent the old mechanical system. So no additional security at all, actually. Other funny thing I found is on their homepage, I didn't mention the blacklisting feature. So there are different variants of this lock, and the basic variant, it's called basic, costs like €300, including the installation. And there is a €600 variant that has a blacklisting feature. And you have to buy this additionally, you have to buy, have a yearly fee, annual fee for this blacklisting feature. And this is a picture from the Facebook page showing how they update the blacklist. So, if you read the contract now, you don't wonder anymore why there is only one blacklist update per year included. So actually, even if you have this premium lock and you pay for the updates, a stolen key, even for non-technician, even if you don't know all the stuff I told you about now in the last minutes, this key still has a value because it maybe gets blocked a year later. Also, the basic devices don't have a blacklist feature at all. I mean, come on, seriously, it's 2013. There are like GSM modules for $20 or $30. You could build in one in every lock, but okay. So, just for the black box analysis of the BG, a key system, the 4 main points are the circumventing, the cost of the materials are more or less the same like the mechanical system. There's no additional security offered, no practical use. Then they used an inappropriate card format, assuming that the UID is fixed and not clonable. The basic design is somehow broken, and also the default configuration, like up until 2009, it was like the default configuration to enable the Baukart. Later they changed it. And also that the blacklist features just once a year, that's ridiculous. However, so customers should not expect any significantly higher security of the new system than of the old system and act careless or something like this. So the other question that comes to your mind probably is, why will crappy security solutions accompany us and have such a long lifetime? Why all these things that we show that are broken don't go away? And the first answer is users don't care. Because you always get the smoke and mirrors and nice marketing sayings from the companies. And every time you present an attack that costs like 10,000 euros, the company will say, yeah, well, see, 10,000 euros, just protect things that are less valuable and no one will use this attack because, the attackers are not insane. The other thing is that, like in this sample with the coffee machine, this is a prime sample, also this one, vendors somehow did not realize that they need to build in an update plan. I mean, in software, for every one of us, it's clear for like 10 years now that whenever you have a security solution, you are in a kind of arms race with the dark side of the world. So you need some kind of update mechanism and update path. And okay, you cannot make a online updating of your program code and hardware that easy. However, for example, blacklists could be updated by GSM. But also, like with the coffee machine, if you design this electronic purse like to be modular and to have an update plan that when you decide to change your card format, you first replace your reader modules and then step by step replace all the cards in the field, and then you switch to the new format and something like this. If you build this in from the very beginning, then you have a chance to do it. Otherwise, you will face very severe costs. And this is something that people that buy the system should be aware of, that and should ask what is the lifetime, the supposed lifetime, and what will what is the way to upgrade it, because no security solution lasts forever. Actually, there's a nice example with the pay TV cards in Germany, which have been broken multiple times, and like Premiere learned it the hard way, but actually it looks like that now for several years they learned how to do it because you need a way to change, you know some kind of lifespan for your security solution, and you are prepared to change it after this lifespan. And if the security solution stays unbroken for a longer time, then you have some, you make money out of it a little bit. You have to price it in, of course, from the beginning. And if not, you should have all these procedures up in place to change all your cards and to change the encryption system. Also, the other thing is that, like I mentioned before, the application creep, that solutions that are in place are then later misused for other things that were not designed for. And you should always be aware that they're probably not up to this high standards that you need for a new solution. So to sum up, so why am I doing this? In general, security is not verifiable, only falsifiable. So if you have a new security solution, you have to go through a series of qualified attacks, and only if you survive them, you can assume a certain level of security. And also, I think it's very important to provide cheap exploits that are practicable. Otherwise, vendors will always claim some kind of practical security, as I mentioned earlier. So my last word is, the cheaper an exploit, the better, and I hope you had a lot of fun, and build cheaper exploits. Yeah, so now for the question, probably the first question will be, yes, I've informed the vendor of the system through the third authorities in Austria.
Thank you for this very entertaining talk. If you have questions for the speaker, please do line up at the hall microphones, 1, 2, 3, 4, and up there as well. While you do that, we have one question from the internet.
Okay, I don't really know if you already said it. What happens with the BG system if you have a power shortage in the building, or if the box where the system is in doesn't have any power?
Yeah, well, then you still have to use the mechanical keys. But so for the emergency services won't get in, but a normal user or a normal apartment owner of this building still gets in because he has his mechanical key.
Microphone 1, please.
Hi, just one information, one question. In France, we have the same system since 97, so it's pretty old now. And for the user keys, for like the post guy, they have put a restriction. So those kind of keys can be used between like after 2 p.m. So maybe I'd like to know if you encountered those kind of countermeasures, maybe some of the doors you can open where you know like your key wasn't allowed to open this door at that time.
This is a theory why I had this 7% of systems that
I was asking if it was like something that was not, because in France this is how it works.
Yeah. The premium variant of the system actually supports clock-based access controls. So maybe this was the case. Yeah.
Yeah, because they try to enforce it in France, but we have a lot of old systems that don't work like this, so it's still easy to open.
Microphone 2, please.
Yeah, hi, thanks for doing the exploit. You mentioned that you informed the company, so what was their reply? Being from Vienna, and it sounds like a typisch österreichische Lösung.
Yeah, actually, I've informed the third AT people, and they informed the company. And I've wrote one page of how I did this exploit and some possible solutions. What are the other card systems they could probably switch to, and how they probably could make it. The only reaction of the manufacturer was like, they don't believe that this was an independent researcher. This is probably some other company.
That is challenge expected for me. So I will try to replicate that. Is your theory and your thesis available in the TU Bibliothek?
Yeah, it's available.
Okay, thank you.
Microphone 4, please.
Hi. Can't you just emulate these cards with your cell phone? Why do you need the ski pass?
Yeah, well, the chip that is built in Android NFC phones only has an emulation feature for ISO 14443 cards. And also up until the very last Android version, it wasn't enabled. You could use Cyanogen mod and then use it, but actually it cannot emulate the system that I have to deal here. So no, not with the chip that it's built in usual Android phones.
Microphone 7 up there, please.
Yeah, thank you very much for this great. What I wanted to ask is, you used 125 kilohertz systems, and you mentioned the long-range readers that are available. Do you know about long-range readers for 13 megahertz systems?
Yeah, well, the 125 kilohertz system was just a small detour to show you other systems. The BG system works on 13 megahertz. And yes, actually, I found a company in Germany that sells them, like for starting at 2,000 euros. There are some physical constraints. So the first thing is, as a rule of thumb, most literature says that you only get a distance like 1.5 of the diameter of the antenna. And the second thing is there is a hard physical limit. That's because this magnetic coupling only works in the so-called near field of the antenna. So when you move out of the near field, there are several models how to calculate the near field, but in worst case, it's like 3 meters. Yeah.
Another question from our signal angel.
So why are the commercially available RFID debugging tools so expensive? Is that due to a monopoly position, or are they really that expensive due to the components used?
It's basically, no, it's not the components. I'm sure it's not the components. It's basically design work, and because your prices on the market are determined by what customers like to pay, or what they pay, and not how much a thing costs. So you have these developer tools, and a company that wants to develop a new system and says okay, I need something to test my equipment with, and I could have a technician work for 1 month on it, or I can buy something for 10,000 euros and have my project finished a month earlier and don't have to pay my technicians. So for them, maybe 10,000 euros is acceptable.
We have time for 2 more questions from microphone 1.
Hello. I wanted to ask a slightly different question. Right at the start of your talk, you showed pictures of some of the keys for the old system.
Yeah.
And I'm wondering, are those symbolic pictures, or are those the actual keys used? Because especially the third key you showed looked like maybe 5-pin or something. So it looked like an analog treehouse of horror.
I'm not. You mean that? Yeah, I have this picture with the 125 kilohertz tags.
No,
probably, yeah.
Sorry, I mean the old system with the physical keys and locks.
Ah, okay. So if this is the actual key?
Yes.
Yes, it is.
Okay.
I mean, yeah.
So this is basically lockpicker's heaven.
I didn't show the backside, so it's not enough to make the key out of just of the picture.
I wouldn't trust that.
Yeah. Actually, there's a nice controversy about whether it's legal to copy these mechanical keys, but it's probably for a talk for another 15 minutes. But I wrote about it in my master thesis.
Thank you, Adrian Dabrowski. Please give him a warm round of applause.